Hello, now I will start my presentation for EEL 6935 Network Science and Applications. The topic of my project is identification of semantic network topology. First, I will introduce the background of this project, and then I will describe the problem in this project. And finally, I will show the simulation and evaluation results using MATLAB. Network science is a new and emerging scientific discipline that examines the interconnections among networks. Unlike model and inference of observed network graphs, network topology is to infer the unobserved graphs by some measurement. The figure shows an example for network topology. In this figure, edges are shown in solid, non-edges are shown in dot, and the observed nodes and edges are shown in dark, and the unobserved nodes and edges are shown in light. This project is to design to identify the topology of a semantic network of words and phrases given text documents. I will first introduce basic knowledge of network topology, including the bus topology, star topology, and the ring topology. And I will also introduce the semantic networks, including ISA, AKO, part of, and the link types, frame systems, and the case relationship. Then I will introduce an approach to identify the semantic network topology called self-organizing semantic maps. Then I will use MATLAB to conduct simulation experiments and get results. Finally, I will analyze and evaluate the results and draw a conclusion. Network topology studies the topological structure of a network. It can be divided into physical topology and logical topology. In this project, we will focus on the second one. The logical topology studies how data transfers in a network, regardless of its physical statement. Therefore, even if two networks have different components, they may still have the same network topology. In general, network topology consists of several nodes and links, and there are many different types of network topology. The first figure shows a bus topology. The bus topology connects every node to a single communication line, which is called a bus. The signal transfers from one side of the bus to the other side. And the second one shows an example of star topology. In a star topology, each node is connected to a central component, which is called the hub. The hub can connect to all the nodes in the networks, and each node has its own connection to the hub. And the last example shows the ring topology. A ring topology connects nodes serially in links. It is like a circle with nodes and links. There is no terminator of the links, and signal transfers around the circle in a certain direction. Now I will introduce the semantic networks. The graph of semantic network is directional, using nodes to represent concepts such as the objects, time, actions, and using edges to represent semantic relationship between two nodes. There are several basic description methods to be applied in the semantic work. First, we use A to represent one node belonging to another. For example, in the figure A, Bob is a teacher. And second, we use AKO, short for a kind of, to represent the relationship between a node and a more abstract node. For example, in figure B, it shows the relation between animals, mammals, birds, and other specific animals named, such as tigers, lion, crows, or ostrich. Thirdly, we use part of to represent relationship between a node and what it can consist. For example, hands are part of the human bodies. And at last, we can also represent the relationship between a node and its attributes or values. For example, in figure D, we can get personal information such as sex, profession, age, and height of John who is a person. Self-organizing semantic maps is an approach to identify the topology of the semantic network. For different sentences or text, if we want to identify their semantic relationship, we can use their relative distances in the map. In more detail, the network will detect the similarity of semantic logic among words from the statistics. The self-organizing map is to find the best matching cell that can activate its topological neighbors to participate in tuning to the same input. In other words, the self-organizing map indicates the metric distance relation between two vectors. Since most words are from a very large lexicon, we could map each word from the large database into a smaller one. The solution is that we put those words with the same or similar meanings into the same or close points. Therefore, the distance between 2 points can be represent the word's similarity with 2 words are placed. This is how semantic maps works in this method. Assume the set of words to be self-organized is Wi, where I is from 1 to m. Then Wi can be identified by a set of its co-occurrent words as equation 1. Assume that D is a correlation matrix and the element Dij of D is the word similarity between words Wi and Wg. Then we can code Wi with the ith row of D as equation 2. And finally, the word similarity Dij can be calculated by equation 3. We should note that the smaller the Dj is, the closer Wi and Wj will be. Now I will show the simulation and evaluation results by using MATLAB. From the map, we can see there are 3 .map files named animal data, animal label, and animal SOM. From the animal label, we can see I will use 16 different animals and their information and find out how they are close to each other, such as the doe, hen, duck, goose, owl, hawk, and so on. Now I will run the program. From the menu, we can see, do you want to run the SOM from scratch? We choose yes. Since the program needs a few processing time, so please be patient while the CR is running. Okay, this is the result of self-organizing map for the semantic network. From the result, we can see that it successfully classified the animals into different groups. That is the semantic mapping. We can see the value of sigma is 0.7. And if we think the cluster boundaries are not sharp enough, we can try different sigma. Now we will try the sigma 0.5. Since we changed the sigma value, the program is run again. So please be patient while it is running. Okay, this is the result for sigma value is equal to 0.5. If we think the cluster boundaries look sharp enough, then we can choose yes and continue next step. We can see that the threshold is 1.5 and the component plane is 9 and the line thickness is 1.2. In this part, we can change the threshold, component plane, and line width. For example, we can change the threshold to 0.3, 0.6, and also we can change the component plane to 3, 5, and so on. And also we can change the line width to 3, 4, or maybe thinner, 2. From all of the results, we can see that the program runs successfully, but there's still some works we can do to improve this project. For example, usually we always have to analyze a large database with hundreds of thousands of words or phrases. Therefore, we should improve the efficiency of this project, making it having more memory space and less processing time. Okay, that is all for my presentation. Thank you for watching.